Okay, so the other thing I did, one of the problems I actually need to mention was printing such a thin layer height. What I was finding was I was getting distortion in our shape. So I spent all this time getting a constant area intake, and then after I'd printed it, and especially after I'd treated it or dipped it in acetone, I'd lose the shape on the flat areas. Now where there's tight radiuses or folds or creases, it's great, no problems there whatsoever. But when you've got like a big flat expanse there, it's distorted, so obviously that's no good. So what I did try was put again, it's a single, this is printed in one piece. So what I did then was put a flange along that edge to try and keep that flat. Now this is coming from, that's what I explained about my sort of design background and trying to break with that way of thinking. You know, you obviously think, oh, I'll just put a flange on there, and if that doesn't work, put a T-flange on there, and all those things can be printed. But obviously I was looking at it as like a fabricated welder, which is my background technically, and you normally put stuff on like this during the fabrication, so you actually fabricate it and actually tack weld it on and then weld it at the end. But obviously this has all been printed at once, so although it's helped on the bottom area, it's kept it on that bottom edge, it's kept it nice and flat on the inside. On the top edge, hopefully you can see on that, don't know whether you guys see that, but along that edge there, it's still bowed. That edge is supposed to be straight. So that didn't work out too clever. So moved on again, and I tried. I actually distorted one quite badly. The new one. Oh, that's one. This is one without the that hasn't been treated, and it's better. I just changed some of the settings, but you still got a bubble. Sort of increasing the area on the intake, so it's probably going the right way if it were to go away, but still it's not constant area, which I was hoping to achieve. So I might play some more with this, but more than likely I'm going to actually think of another. I've got some ideas, but I've got, I might need to think of another idea of doing the inlets, whether I do them as a printed part or as a composite part. I'll just have to have a think about it. So I didn't want that to stop me from testing, because I didn't technically want to test the ducting with it not being right. So it gave me an excuse then to print the ducting as it were on the airframe, and it also means that at least I'm getting the accurate results, because it's going to take into account the actual fillets on the inlet. So I've got nice curved surfaces. I mean, they are sharp, but they sort of scale to the model, and that's going to give me more accurate readings on what I expect from a thrust perspective. So this part is printed just like a traditional 3D printed part, so it's not meant to fly or be light enough to fly. I'm just interested in a good model of the intake, which I'll test in the frame. And it also gave me a chance to actually experiment with the finishing on it, because I'm hoping to actually use the printing technique for the moulds, composite moulds. And on this one, I don't know if you can see it, but I actually printed a little bit too fast, and so I've got some what they call ringing. That's just where the printer oscillates a little bit, and you end up with vertical lines in your print. They're ever so slightly, you can sound them out. And I was a bit of a rush with this one, so they're not completely sounded out. But I mean, it's a pretty good part. Really shows up the hunter's lines and curves, which I really like. So you can see inside that. Hopefully you can see inside that. How that looks on the inside. This structure is what they call infill on 3D printing, and that's the. So this is basically exactly how it's going to be on the plane. Forget about what's inside here, because obviously it's way too heavy. And then we'll have our, first we'll have our motor with our rotor on it, and the shroud, and that just pushes in there. That's a bit tight. There you go. and then obviously you've got your ducting and your exhaust to go on there. So yeah, it's nice to get a feel for the size of the plane, the finished model. So yeah, really happy with that. Good experiment. And then, like I say, when I actually come to testing it, in the frame, we'll just drop it in the scales a sop, and then I can test it and get a real feel for what sort of thrust I'm going to achieve with my final motor rotor setup. So yeah, a lot of this is very new to me, so I'm just making it up as I go along. Having an absolute ball along the way. I'm really enjoying it. Learned a hell of a lot. 3D printing, design, model aeroplanes, the whole shebang really. Electronics isn't my strongest point, so I'll be asking a lot of questions on the forums when I get to that point. So yeah, so that's that bit taken care of. Now, something that actually happened, which I was actually quite surprised with, when I was doing the shrouds, you know, I had modelled up the rotor, so I thought, oh, what the hell? Let's just try and print a rotor and just see what we came up with. And I know some guys again then printed in Shapeways, so I thought, you know, I've got a printer here. Let's see if I can do it. And you know, where Shapeways got their printers are thousands and thousands and thousands of dollars worth of printers, really good kit. My printers were about $2,000 when I bought it, and it's got quite a lot of upgrades. But anyway, so I never really believed that something like this would be achievable, to actually print something that we could actually use, because then again it opens up a huge amount of opportunity for actually designing rotors to suit an actual airframe, a duct, a shroud, a motor setup. So yeah, so I got a little bit sidetracked this week, and I just concentrated on trying to get a printable rotor that I can use and test. So this is probably one of the first ones, probably the second one I printed. I think the first one was red. So it's just a copy of the 40mm AOL. Or something like that. I'll look it up. Rotor, and yeah, that gave me the confidence to actually pursue it and push it a little bit. One thing I had to do with this is you got to print with supports, because you got really big overhangs. Yeah, when you're 3D printing, if you're going up 45 degrees, imagine 45 degrees from the build plate, you can normally get away with it. But anything over 45 degrees, the printer can print in open space, so there's nothing for the actual filament to fuse to, so you end up putting like a support. It's like scaffolding really, and that doesn't leave you with the nicest of finishes on that supported face, which explains why these are quite horrible. So there's another method, because my printer has two heads, where you use another material as the support, and then ABS as the main material. So you actually print like the negative, as it were, of that shape. And then when the ABS is printed, it's actually printing on top of that negative. And when you finish, you gently pull it away, and whatever's left you can dissolve away, and it leaves the ABS intact. But like I suppose lost foam with fiberglassing, same sort of thing, where you got fiberglass and acetone burns away, it melts the foam. Exactly the same principles. So I'd never used that technique. I never tried it, and it gave me a good excuse to actually pursue it and see if we could do it. So yeah, so this is the 30mm, one of the first ones on the 30mm, sorry, 28mm rotor. Now this is basically based on the E-Flight, the MIG rotor. So I sort of modelled it basically on what the injection moulding looked like, and I suppose designing for injection moulding and designing for 3D printers are a completely different thing. So again, it's something I need to get into my head when looking at the stuff. You know, it's one thing designing for injection moulding, but you could design a specific way for the 3D printing side of things. So as you can see, the internal hub shaft kept on snapping off. It just wasn't supported enough, so there's no way I could run that up. But it did actually show me that I could print something like that, as delicate as that, with the correct material, with the hips and the ASB. So from that I then went through trying different coloured materials to find out which is the best material, the best colour to print with. Not all colours print the same, so some are a little bit more brittle, some need more heat, some need more faster speeds, etc. So I went through, and there, you know, I couldn't really find one that I was completely happy with, so I got some just natural ABS filament. So it hasn't been messed with in that respect. It hasn't had no dyes or colours put in it, which makes sense. So you're getting just pure ABS rather than messed with acid ABS. And then what I did was I changed the hub. I don't know if you can see that. I'll try and get some photos. Hopefully, I changed the hub so it's, you know, there's like 5 flanges coming out to the spinner, as it were, and they're printed fine. The biggest problem I had was getting the hips out, because it gets recessed right down the bottom, and it was a nightmare getting it out. And then it occurred to me that I didn't technically need the spinner part of the rotor on there because of my constant area. And if you look in there, the airflow is ducted over the spinner anyway, down the line. So I decided to lose that section of the spinner, and in its place, instead of just ribs, put like an internal little internal rotor in, and the idea being is this is going to blow air directly onto the motor. Okay, so you actually can't see it here. Imagine the front face of the motor. You got all these little holes, cooling holes. So the idea is that the air is going to get sucked in, actually pushed through those holes now, and hope to keep the motor a bit cooler. I know some of the real high-end ducted fan manufacturers actually use the same technique. I haven't seen it in something as small as this. But that just then goes to highlight the advantages of 3D printing again, because I expect trying to manufacture something or do the molds for something like that, as complicated as that, would be extremely difficult. So that's where I ended up a couple of days ago, and then I improved it until I could print them one after another really successfully in whatever configuration I wanted in the natural ABS. Now these haven't been finished yet, so they've come off the printer. The supports either been moved up, taken off the pliers. The hip support's been taken off the pliers, and that's it really. So, you know, I've got all my tips looking really nice. The supported surface isn't quite as nice as the top surface, but you know, we can sand that out. So that looks absolutely, I mean, they've just come along amazingly well. So this is my bag of good ones. Oh, there's the original. Well, that's the original one there. So I'll go 3, I'll go 5, I'll go 7, I'll go 9 to try, 9 blade to try. So yeah, so like I say, if I want to make that into a 4 blade, it's really easy. It takes about, I don't know, no more than 5-10 minutes, and it can be on the printer printing. So I can change the configuration super easy on these, and so it works. I haven't really done much with the actual the cord on these, as I don't really know a lot about it from a sort of aeronautics point of view. So it's just a case of print and try really at the moment. Hoping to learn a lot more about propeller design and rotor design. So that was great. And then last night I finished one completely, which is on the rig. And what I did was, I wasn't 100% happy with or confident that it had fused. All the plastic layers were fused. So I know I've read on the forums. I know Nitro and other people actually, when they come from Shapeways, they actually sort of soak them in resin, and that soaks into and holds everything together. So I did something similar with this one here, except I just used really light, thin CA, and that's worked really, really well. You take the shroud up actually. yeah, I printed a shroud as well for when I test these and compare them as well. Sorry, an inlet ring. So when I test these, I can get, you know, that's what I'm hoping to compare them against. Just, you know, in that configuration with a shroud and the sorry, with the inlet ring and a shroud. I don't know if you can actually see on this. Okay, I've got a couple here that I've done. I've done a test one. So I've done one where I've sort of done a more sort of no, that's not it. What's those ones? This one's here. So I've done a couple of samples where I've done like an acetone finish on it, just to see how it reacts with the material and whether it was an option. Because, you know, with the acetone you get a really nice surface, very smooth surface, so you get less sanding to do. Not that there's a hell of a lot of sanding to do on that really. I expect you could run it as it is once you've balanced it and it'll be good. So this one here has had like an acetone finish on it, so it's been dunked in acetone. No, actually I hand brushed the acetone on this to try and just get a better control over it, and it's actually worked out pretty good. I mean, you can see how stiff it is. So it's not a, you know, I haven't dismissed the idea completely. It probably might take a little bit more technique on my point, but it's definitely workable. Definitely be workable. I'll just show you, try and compare how stiff the blades are in comparison to each other. So this is the original one, and this is the printed one. The printed one seems much stiffer than the original one, but then again the original one, the thickness of the blade is really thin. It's really thin. So 0.41. That's this good change in thickness as you go through the. It's going from about 0.55 to 0.38. On this one, I'm going from 1 mil down to, I think it's constant, 7.3. So it's a bit thicker. And weight-wise, I actually haven't weighed these yet. So let's have a look weight-wise. So from a weight point of view, let's take something similar. Okay, so the printed one's 0.6 grams, and the original one is 0.54 grams. So the original one's slightly lighter. Let's try the new type, this type here. Fire blade, yeah, so that's 0.45, that's with a little internal rotor, and the original one was 0.52. So yeah, so the new version is actually lighter, and I expect it's going to be stronger in the end. Because if you look over here, I've done one where I did a couple in acetone, a couple of the blades in acetone and a couple of blades CA'd, just to get a feel for the how stiff they get. So this is the acetone one, and this is a CA one. The CA one's a lot stiffer than the acetone one. The acetone one's still got a lot of flexing, so but the CA one's actually stiff as hell. So yeah, there's some more work I can do on these. I might actually try and drop the thickness of the blade a little bit later on, but yeah, it's probably going a little bit too extreme at the moment. I need to get on with some testing and get on some. I've gone off piste a little bit with with a lot of this stuff, so I'm going to leave the rotor design for a while and just concentrate on getting things to a point where I can start testing, start building the airframe. Okay, so last thing I'm going to do is I'm just going to run up the fan quickly on the jig, because this is the one I did this morning. Balanced really easily. I was actually surprised how little it was out of balance. So I balanced it and then fitted it and ran it up, and it ran a treat. So I'll do some tests at some point so we can compare my version with my rotor to the original, just on the thrust and amps and whatnot, and just see if I'm in the ballpark. So okay, so that's it. Voice is a bit sore. I'll try and do these videos a little bit more often. Okay, cheers.